We do not have question yet for you, Benedikt, but we had one pending question for Vitor, so maybe we will leave people some time to ask you question, and we will come back to you right after this one. So Vitor, there was this one that came after it. How do you measure leakage through each component with your method? I think the question is, are you able to seal any kind of component with your method?
Yes, we use the how do you call it, stripes? No, I don't know how to call it. Yes, like an adhesive tape. Yes, and with each type of leakage group, we would seal accordingly. For example, the mechanical ventilation, we seal the inflow and outflow. Okay, and we measure and we get the offset from the default value. After, we will use measure the heating and air conditioning. So we will seal the heating and air conditioning and measure again, and until a point where all the leak types were sealed, and then we measured, and I think it was like 7% of the total air leakage of the envelope that was could not be associated to any of the types that were in the initial plan.
Okay.
I would like to add something, if I have time, to the first question of the quadratic equation. Well, the effective leakage area, it supposes that the discharge coefficient is equal to 1, so that all the flow has a type of the same type of flow. You know, I think everyone gets what I'm saying. So that's the maybe the next step, because if I would go with each pair of airflow and pressure difference, we could get the discharge coefficient or the evolution of the discharge coefficient between different pressure differences, and maybe that's the next step to address when we are studying these types of this variable, you know. So maybe the quadratic equation could help in that part, because it divides turbulent and laminar flow. But I don't know if the uncertainty would be higher or lower.
To be investigated.
Yes. Next episode.
Thank you. So we now have questions coming for Benedikt. So first one, Benedikt, and thank you, Vitor, sorry. How important is the value for the total tight wall? The difference is probably difficult to determine in reality.
Yeah, as I see, most of the questions are heading in this direction. Yeah, it is of course important to get these measurements up until now for the tight wall, because as I already told you, that the sound transmission through the tight wall has a large influence on it. For the implementation in real buildings, it might be an opportunity to, if we are able to localize the leakage spots there, to measure, to do this measurement at these leak spots, and then determine parts of the building where the wall is not leaky at all, and then get this as a reference method. But we have to determine this in the future. Yeah.
Okay. So yeah, I think a lot of the questions go in this
right.
direction. So some reduction depends a lot on construction type. If you're light, does it mean that the potential of acoustic method to quantify leak may also differ depending construction type? I think.
Yeah, it depends on different construction types, and we saw that it works. The outlier and this correlation were predominantly for measurements with non-parallel leakage paths. which might be as expected, and for the very small leaks. So for the very small leaks, the influence of the construction was higher than for the larger leaks. So we still have to advance these methods for very small leaks, and I think it might be for the application in real buildings very hard to get indirect air paths with an acoustic method due to dampening inside the walls and all these effects.
And so, with all the configurations that you have tested, have you seen some configurations that are more complicated to quantify with the acoustic approach, that are less correlated?
As I already told you, with indirect air paths are more complex, and the very small leaks are the two configurations which are less reliable.
Okay, and have you checked the N coefficient of those, the airflow coefficients, the N value, when you've done the measure?
Of course we determined these coefficients as well.
And have you seen a correlation between the N coefficient and the difficulty to quantify with the acoustic approach?
Not yet, but that's a good point to do in the future.
Okay. Okay, we have another question. Oh, yeah, here it is. Maria is struggling to copy it, but have you used ASTM E3158-18 standard test method for measuring the air leakage rate of a large or multi building?
No. No, I haven't used this on it.
You use ISO reference for?
Yeah, it's for the air tightness measurements. I use the ASTM load or measurement standard. What's this? And the ISO standard.
Okay. Are there also numerical study on this acoustic approach, or have you done only experiments for now, or also?
Only experiments up until now. Yeah.
Okay. And have you heard about existing numerical studies?
No, not about this specific approach. No, not yet.
Okay. Thank you very much. And so, yeah, what you said, you've not studied. Is my last question, because I have one also, and we still have time, so I can ask it. Do you have different N coefficients to go back to this according to the configuration?
Yes, of course. They're different, of course. The N and C values are different for each of the configurations, and we determined them as well. But I haven't done analysis if this correlates to the acoustic methods.
Okay. So, and do you remember the range of variation of this N value from 0.5 to no?
It was in between 0.5 and 1, somewhere in between them. So, but
there is variation.
There's a large variation. Yeah, there's a variation between them. Yeah.
Okay. Thank you very much.